So Aquacold is a novel question answering tool, and it helps users find answers to complex questions over linked data. And the acronym stands for Aggregated Query Understanding and Construction over Linked Data. It's been developed as part of a PhD project for the PhD that I'm doing. And it combines a combination of natural language search, crowdsourced query labeling and voting, a faceted query builder interface, and query templating all into one tool. So we think this approach has got a lot of advantages over existing systems. And so this short presentation is just going to go through and talk a little bit about the problem that the system solves. There'll be a short demo of the system as well, and then I'll talk a little bit about some of the evaluation that we've done. So I think first thing to establish is really kind of what do we mean by question answering? And in the terminology that I'm using, it is providing direct answers to questions constructed out of natural language. And this tends to be the preferred mechanism for users who are looking for answers to questions, rather than displaying links to web pages or other documents that may or may not contain the answer. And although a lot of main modern search engines and question answering systems at the moment can answer quite straightforward questions like Google's, such as who is in the current Manchester United squad, the more the complexity increases, the more often that question answering systems tend to fail and either not provide the correct answers or not provide any answers at all. So I've got an example here, again in Google, it's asking who's in the current Manchester United squad, and you get the direct answer, you get the details of the people rather than just links to websites. But if you increase the complexity of that question slightly to something like Manchester United goalkeepers who were born in Germany, not only do you not get the direct answers, but also in this particular example, the first link that was shown is actually incorrect because the person was born in Copenhagen rather than Germany. So this is just an example of how when question complexity increases, often accuracy decreases. And the root of this is really that computers find parsing unstructured text and human language quite complex because there's lots of contradictory rules. And it's particularly true of questions that contain multiple entities that have got different relationships that connect them. So like played for Manchester United, born in Germany, those sort of property value relationships, especially when there's quite a few of them in a question, can be quite difficult for computers to parse. Even with modern systems that use deep learning and machine learning methods, they still find it difficult, particularly if there's other notions thrown in there as well, such as grouping, comparisons, and aggregation. So this is why linked data can really help, because it has a number of advantages over using it as a data source rather than unstructured text. And the key advantage, I think, really is that the relationships between the entities and the relationships between them and the entities themselves are defined explicitly with URIs. So it's very sort of clear what is relating to what in what way. So there have been quite a few different approaches for using natural language as a question answering input for linked data. And uncontrolled natural language is one of the sort of the ideal way of doing it. So you just type a question free of any constraints into a question box, and then it would go off and search linked data source, and then you'd get the answers back. And this is really kind of the ideal approach that we want. It's very intuitive. But at the moment, even with the state of the art, the results tend to be unreliable. We'll see later some of the scores in some of the benchmarking that we benchmark against. It's still is very difficult, particularly as question complexity increases. Again, reliability of the answers tends to decrease. So another approach that people do is using controlled natural language, where the actual wording is specific. So you have to use specific wording for specific things to form your query. And although this is quite readable because you're using text rather than code, and it allows quite fine-grained selection of exactly what you want, it's quite inflexible. It doesn't allow for ambiguity, doesn't allow for slang. And if there's a mismatch between kind of your vocabulary and the data's vocabulary, it doesn't really resolve that. And it also results in quite verbose and extensive queries, as in this example over here. So some of the challenges we're aiming to solve with this is returning accurate answers to complex questions, complex natural language questions, allowing questions with multiple entities to be answered, also allowing operations such as grouping, comparison, aggregation, and having a degree of exploration so we can see the data that we're answering questions over to see what kind of questions that can be answered, and also ensuring scalability as well. And we think that Aquacold and our approach like it may be a solution for some of these things. So this is a screen grab of the Aquacold interface. Just before I do the demo, I'll just show you, point out some of the key parts here. So we've got the natural language labeling and search bar at the top, and this is both where you label your results and also where you search them as well. So it has two functions. Then we have the query builder controls here, where it says new subject, new property, and new property value. And they allow you to add filters to your data to get the information from the linked data web and to filter it down. Then we have the filter set up here, which is just all the different filters that have been added so far. And then the results grid, what appears in the results grid is the results of applying those filters to a linked data source. And throughout the examples here, we're going to be using DBpedia as the linked data source. So I want to show a quick demo. So I think I need to just stop my share quickly and switch it to the demo window. Okay, can everyone see that okay?
Yes, we can.
Okay, so this is kind of a process sort of from start to finish of how we add the different filters to the grid and how we work with labels and how we answer the questions. So we have 3 different types of filters: subjects, properties, and objects. We can also specify relationships in the query builder and also modifiers like greater than, less than, order by, and limit to. So in this example, we're going to be asking the question, which goalkeepers have played for Manchester United and Luton Town? So we search for Manchester United in the value filter. And next we search for Luton Town. And these are the options. We select team, Luton Town FC. So that's bringing back everyone that played for Manchester United and Luton Town. And then we're adding in another value filter here. We're looking for goalkeeper, and it gives us the option of position goalkeeper. So we select that as a third filter. So that now gives us all the goalkeepers for Manchester United and Luton. And the next step is to label and save the results grid. So when we've set up, added all the filters to get the results that we want, we can add a label which then becomes available for other users to then go and search and find. So they don't have to go through the query builder step. They can just type a natural language question in here and get their answer. So here, this is another user who's looking for every goalkeeper who's played for Manchester United and Luton. Oh, sorry, if this was the same user, so the same user then also has the option to template on certain items within the query. And what it does is it looks at matching words within your question text and matching filters, and it asks whether you want to use them as a template to make multiple variations of the original query. So, and it doesn't just use this just specifically with the wording that you've got. We use a number of techniques to kind of do like fuzzy matching. So we can use paraphrasing and alternate words and stemming as well that we use. So we can have lots of different related questions now based on that original template. So now we can also look for every goalkeeper who has played for another 2 teams. So the next step you can do is you can vote these, the labels and their associated filter sets up and down, and you can also edit ones that other people have created. And this kind of helps you to see which are the ones that people think are good, which are the ones that people think might not be accurate, and also any that you might want to adapt to form your own query. So that's the voting there, voting up and down. And in this example, we're going to remove one of the filters, remove the goalkeeper filter, and replace it with something else to look for someone who played in a different position in the team. So if we just look for the property position, we can see all the options there. So we might want to search for midfielder. And then it again gives us another option to template this. So we can template on the midfielder section here as well, and then it will give us the option of searching for anyone in any position who has played for any two teams. Okay, I'm just going to pause the demo there and just return to the PowerPoint. Okay, can everyone see the PowerPoint again, okay?
Yes. Okay.
So just an additional note on the templating. It can answer not just questions that have different subjects. So if you think of a question, which rivers flow into a German lake, if that was the question, if that was templated, it would be able to answer rivers that flow into a German lake, also rivers that flow into a lake in Germany, so different syntax, different subjects, so which rivers flow into an Italian lake, which rivers flow into a French lake, and also questions that have got a combination of different subjects and syntax, like rivers that flow into an Italian lake, rivers which flow into a lake in France. So this just shows that the system can be used to produce templates for quite a large number of different questions based on one particular sort of STEM or base question. So moving on to the evaluation section then. So to get an idea of how the system was performing, and we evaluated it against questions from the 9th annual Question Answering over Linked Data Challenge, QALD9. And that's one of the main campaigns for knowledge-based question answering. And it consists of 408 questions. We used a training set for our experiment. And there's quite a wide range of different variations of questions in there, from simple, like when is Halloween, to complex, like give me the capitals of all the countries that the Himalayas run through. And each question is supplied with a gold standard set of answers and associated gold standard Sparkle query so that we can measure how well people are doing. As I mentioned, DBpedia is the knowledge base for all the different questions and for their answers as well. And in order to try and sort of cover all the bases, we ran two separate evaluations, a user evaluation and a technical evaluation. So the aim of the user evaluation was to measure how successfully users with a wide range of backgrounds and technical abilities could use Aquacold to answer the different questions. And we ran a short survey before they attempted the experiment that captured their proficiency with computers and also with spreadsheets specifically, and if they had any previous knowledge of linked data or Sparkle or anything like that. So the way that we did it is we had 5 questions taken randomly from the 408, which were assigned to participants. But one of the big challenges was to try and mimic what a crowdsourced system would look like and be like. Was quite challenging because there's many different states that it can have. So the solution we came up with was that we'd use a number of different servers that each had a different amount of predefined quality and quantity of data on it. So server 1, when people went to, it didn't have any pre-existing data available. There were no labels that other people had done. Participants had to just use the query builder, so use the subject, property, and value controls. Server 2 had all the gold standard labels available, so users just had to search for them in natural language and they could get them. Server 3 had a combination of correct and incorrect label and filter sets with randomized vote scores, and that also gave us an indication about how important people found the scores that were attached to the different labels. And server 4 had labels and filter sets that were similar to the gold standard, but had one entity that was different. So they had to delete one filter and then add one of their own to get the gold standard answer. And server 5 had all the labels and filter sets that were created by previous users. So that kind of mimicked how the system would work in the wild. So previous participants, their answers and filter sets that they'd chosen went into that server. We also ran a technical evaluation, and the idea of this was to kind of work out how well the system could perform, what's the sort of top end. So this was carried out by myself, the system developer, to try and sort of negate the chance that lack of familiarity with the system would impact the results. And I tried to answer all of the 408 questions with Aquacold. And there's 3 sub-evaluations within here. We looked at query coverage, which is the amount of questions that can be answered by the system, a comparative evaluation comparing the results that we got against competing systems in the QALD challenge, and also template coverage, looking at how many templates were generated when we answered the QALD questions. It's just a diagram sort of showing the flow of the how the evaluation worked. I'm going to move on quite quickly because I'm conscious of time. So the results we had 30 participants who took part in the user evaluation, signing up at Prolific, which is a website for getting experiment participants. It was less than expected, quite a bit less than expected, unfortunately, and there were some reasons for that, which we'll get to a bit later. In total, we had 150 questions that were answered. 77 were answered correctly, 11 partially correctly, so one answer was correct out of the answers they gave, 46 that were completely incorrect, and 15 that were abandoned. And we calculated the total cumulative precision and recall and F-score of all those attempts and got to 0.52. When we looked at the order that the questions were taken in, we could see there was a slight increase after question 1 in the terms of F-score and average percentage of correct answers, but it was quite slight, and it's a small participant number anyway. So there was an indication there, but there wasn't anything definite. Looking at the results per server, we could see that server 2 had substantially the highest number of correct answers, which kind of makes sense because it had all of the gold standard labels that were in there, were preloaded with it. And there was no immediate sort of information that jumped out as to the activities on the other server. But when we looked a bit further into it and we looked at the log files of what people were actually doing, it gave us some quite good information. So on server 1, they had to use the query builder, and we could see from the way that they were using it that there was quite a bit of confusion as to when they should use a subject filter, when they should use a property filter and a value filter, particularly the subject and value. There was a lot of mismatch of those, which kind of indicates they may not understand it. And they also went through a tutorial as well, I should say. Before taking the experiment, they did a tutorial where they took 5 test questions. So on server 2, as I mentioned, we had much higher number of correct answers than other servers. On server 3, the main thing we saw here was that users and participants were willing to kind of look beyond when they saw a question that had was being incorrectly scored, that was either wrong and rated high or low and rated, or either way around, they were still willing to persist and look at the other labels. On server 4, interestingly, we found that all users, when they received a partially correct filter set, they did attempt to edit it by removing a filter and adding their own, which kind of understands that they understood the concept of having the filters and how they work. And server 5 was a bit disappointing because this had the least correct answers out of all the servers, and showed no sort of benefit. But we think that may be to do to the low participant numbers, and that with more participant numbers, that gives the chance for more data to be seeded and better results to come from that. Moving on to the query coverage. So again, this is in the technical evaluation. So out of all the 408 questions that were available, 342 were answerable with Aquacold. So this is myself trying to answer the questions. 52 were answerable and 12 were partially answerable, by which we mean at least one answer was correct in the results returned. And the reason for this is basically to do with the way that the query builder maps with producing Sparkle queries. And I think that the more that we improve on and add to the query builder controls to incorporate relevant Sparkle elements, the more questions we'll be able to answer, because there was quite a few Sparkle operations that the questions required that we didn't kind of have a map for with the query builder controls that we had. So moving on to template coverage. So we looked at the 342 questions that were answerable, and we found that templates could be produced from 227 out of the 342. And that gave us quite a lot of query labels and associated filter sets, 839,938 that were produced from those 227 templates. And that works out at an average of around 3,700 potentially answerable questions per template. And this demonstrates kind of how templating can really help Aquacold scale rapidly. And although it isn't a pure algorithmic approach to answering questions from linked data, the scalability that the crowdsourcing allows can really help the answerable query space. Most of the time when the templating failed and you think it would work, it was because there was no way to map between the filters, the labels in the filters, and the words in the query. So for example, the query, give me all taikonauts. A taikonaut is a Russian astronaut. The filters that were required to get the right answer for that was occupation astronaut and nationality Russian, but neither the word astronaut or Russian appeared in that question. So there's no way to map between those concepts. So lastly, going on to the comparative evaluation. So we sent the results from the query coverage results that we had, we uploaded to the Gerbil QA benchmarking platform, so we could compare it against other linked data question answering systems that also competed in QALD9 with the same data set. And it gave us a total macro F1 QALD score of 0.62, which is higher than the other systems that were recorded. So that indicates that the system can be used to answer more questions than is possible with those others. So just moving on to kind of an overall summary then. So we looked at Aquacold, which is a novel question answering tool that combines natural language search, faceted query building, and crowdsourced templating to answer questions from the linked data web. And the evaluations showed that the system can answer a wide variety of question types, and also that the templating can vastly expand the answerable query space based on a small number of templates seeded by users. Most participants can find the correct answer, we can see from the evaluation, using the natural language system if it's been seeded by the crowd previously, and can also use the grid controls to refine partially correct answers, partially correct filter sets to get their answers as well. The participants were less successful generally when filtering answers that were incorrectly labeled by other users, or when they had to use just the query builder component, so just creating those subject property value filters. And they did report quite a bit of confusion as to the different types and what they were and how they related to each other. And we did see some indication of participants that reported a greater experience of spreadsheets being better when they had to use just the query builder. And that kind of makes sense because it's a similar interface to do with grid-based interface and dealing with data. There were quite a few limitations, both of the system and also the evaluation as well. We had a much smaller cohort of participants than expected, so that made it quite difficult to identify any really consistent patterns in the data. There was a half-hour tutorial they did beforehand, and the experiment itself took 40 minutes. So it was about an hour and 10 minutes to complete the experiment in total, which is quite a long time for people. And it was more than had been anticipated. But I think the system kind of grew in complexity, so the tutorial needed to be longer, and that made it difficult to get participants to be involved. And that also, I think, impacted the cohort size. Also, we tested only against DBpedia. We didn't test against any other knowledge bases. And an additional limitation, you can say, I think that there is an argument to be made that you can only really make a limited comparison between a hybrid natural language question answering system like Aquacold and systems that rely just on a computational approach. I mean, I would argue that for the end user, the result is the same. They type their question in, they get the results. And the templating system really goes some way to expanding that query space. but there are some limitations there. So finally, just moving on to future work. So I'm working on an updated version, sort of based on the feedback from the previous experiment, which gets rid of the need for users to kind of manually add filters themselves and just suggests filters, the filters that users may want to have based on the text of their query. And I'm hoping that this will make it much faster and easier to use, and should cut down any future experiments and tutorial length quite significantly. And I'm using Word2Vec to kind of order the different suggestions for the user based on their query that's been sent. So that's a whistle-stop tour of Aquacold. So thanks for listening. The experiment is still available if you want to give it a go. It's at that URL. It is, you know, it's kind of it is a bit buggy, rough around the edges, some may say, but it is there if you want to have a go. There's also my Twitter handle, or the Twitter handle for Aquacold there, and my email address too, if you want to get in contact.